What's up guys, welcome to the series about design patterns and how to implement them on AWS using only serverless services. Every legacy application gets to a point where the code is no longer maintained and the application cannot realistically be modified by developers easily. It may be difficult, sometimes even impossible, to modify this type of applications. So in this episode of Serverless Patterns, we will look at one way we can add new features, new functionality, and fix existing stuff to a near-dead legacy application that no one wants to touch anymore. So let me demonstrate how to use the ambassador pattern to first add new features to the application and second, don't break any existing ones. So you have a big legacy application that has no tests, that is so fragile, and that is tightly coupled. You know, the type of legacy applications that we all love to hate on. But now you have new requirements from business to either add a new feature to it or to fix a bug or improve an existing logic. So you start thinking, rather than adding this new feature to the existing code base that no one want to touch, wouldn't it be better if you add it to a separate entity, but still have this new entity report to the existing legacy, keep clear communication channels with it, and react to requests coming to and coming out of it? Sort of how a country would appoint an ambassador in a different country to delegate some of responsibilities to them. Now, the second use case that really channels my thoughts into this specific pattern is when I have multiple services and every one of them is written differently, uses a different language, uses a different framework, maintained by a different team. After all, that's the whole reason of having microservices in the first place, right? But now I want to add a common feature to all these microservices. I can either go and write this feature into every one of these microservices, which realistically doesn't make any sense because every microservice would probably be owned by a different team, written by a different language, framework, yada, yada, yada. So I can't really just build a library that they can all share because, again, they are very dissimilar. We will go through a detailed implementation in a minute when we get to the diagram. But for now, an easy way to visualize the ambassador pattern is to think of a proxy or a sidecar. So you have your legacy code base, and then next to it, you're going to add a proxy or a sidecar that's going to maintain clear and constant communication with the legacy code, and to which the legacy code will offload some of responsibilities. It might look a little bit similar to the Strangler pattern, but there's a big difference. We use Strangler pattern when we are migrating away from legacy to a microservices-based application, but we use Ambassador when we want to keep using our legacy, we just want to introduce new features to it, or we want to fix an existing behavior, an existing logic in it. So keep that in mind. Now, some considerations for you should you want to use this pattern is be mindful of latency. Every time we add a new component to the network, it will introduce a little bit of latency. Of course, using serverless to implement this pattern, it will solve a lot of our problems out of the box, but latency will not be one of them. And the second consideration is actually related to the second use case. If you have only one framework or you have only one language across your microservices, you're better just using a library or a layer or an extension or something that all the microservices can reuse. So let's jump right to the diagram. I want to show you how you can implement this using only serverless services. Say you have a legacy e-commerce application. Your application is hosted on an EC2 instance. It communicates with a legacy database, and then it is hosted behind an API gateway. When one of your customers make a request, the request goes to API gateway, then it gets forwarded to the legacy application, then some cooking happens there, and your legacy application returns back the response to the API gateway, which then relays it back to the customers. So what we are going to do here is we are going to introduce an ambassador. So let's start simple and use a Lambda function for this. And this will be my ambassador. So now every request coming from the API gateway will first go through the ambassador, which will either have new features or will do the required computation before forwarding the request back to the legacy application. So let's say we want to introduce a new way of calculating taxes. Taxes ambassador. And let's say we have all the logic to calculate the taxes right now in the legacy application, but I need to add something on top of it. I need to maybe include a new variable. Maybe I have a new business rule that says, check if the customer has left their country in the past 6 months or something like that. So what I can do right now is I can build that logic in my ambassador. So here's how the requests will flow. Requests are coming in from Amazon API Gateway. If the request concerns something else, then it will go directly to my legacy application. But if the request starts with taxes, then API Gateway will redirect it back to the taxes ambassador, which then, let's say that needs to go to an Amazon DynamoDB table to fetch a new set of rules, whatever, just giving it a quick example, and then add those rules onto the payload before forwarding it back to the legacy application, right? So rather than adding this logic to go to the Amazon DynamoDB in the legacy application, I actually extracted it and I put it in a proxy or in a sidecar. The way you actually see this used a lot is by using a container or using, a Docker container. So it's either ECS or Fargate, and that would still be serverless because Fargate is serverless. But I wanted to stick with Lambda functions for this implementation. Another use case might be that you want to check with the warehouse whether the items are actually available in store before making the purchase. You can, of course, go to the legacy application again and write code that has to check with a different microservice, with a different database. But the whole reason here is that we don't trust our legacy system. It works and we don't want to touch it. We are afraid to touch it because it's so complicated. It has tentacles here and there and needs fleet of Avengers to work with it or whatever. So again, I will use another Lambda function that I'm going to call it warehouse ambassador. And I will redirect all calls that are coming from the API gateway that start with, so I'm just gonna say checkouts. Then I want them to first go through my ambassador. My warehouse ambassador will have to check with, I'm just going to put here another API gateway because probably it's to check with the warehouse API. If no, then we can actually break the circuit right here in the warehouse ambassador, answer back, and you see the pattern here. We can have a fleet of ambassadors. Every one of them is its own Lambda function, so it can scale separately, it can be throttled separately in case there's a problem. And then we are adding actually new features to our application without risking changing anything in the legacy. And that's pretty much it, guys and girls. This is the ambassador pattern. Again, use it not when you are decoupling your legacy application, monolithic application, and moving it to a microservices base. That's when the strangler pattern fits. And we have a whole episode specifically for that. Use this when you want to add new features to the legacy, but you don't want to touch the legacy. I hope this helped. I have on my list the webhook pattern coming in a couple of days, so make sure to subscribe for that, and see you in the next one. Peace out.